All right, this is the second half of topic 1.5. We had a little break in the video there. I apologize for that. So we're looking at this one, and this is kind of a weird way of saying that we have one function composed inside of another. It's just instead of calling that function g, they're calling that function 15 minus x squared. So really what we're doing is f of the limit as x approaches 3 from the right of the function 15 minus x squared. I'm going to use Desmos to kind of illustrate it a little bit. So there's my function. If I look at 3 from the right and 3 from the left, it almost doesn't really matter. It looks like it is, I'm not looking at 3. That's 4. 3 looks like it's at 6. So let's see what's actually going on. If I actually just put in 3, I get 6. So I know that coming at it from the right, it's 6. So that means I would be looking at f of 6, and you'll notice on this graph here, f of 6 does not exist, okay? But I know that the 3 is at the right side, so I know that I've got to be coming at it from, or sorry, it's at the left side, so I know I've got to be coming at this from the left side. So I'm going to find the limit from the left side. So this is the limit as x approaches 6 from the left of f of x, and I know that that value, if I scroll back up here, is equal to 1. Okay. All right, kind of the same idea on this one right here. Excuse me. I'm going to find g of the limit as x approaches 2 from the left of 2 minus x squared. So I'm going to use Desmos again. So it's 2 minus x squared. And then they wanted me to find what's going on at 2. So I'm going to find f of 2. All right, and you'll notice, so if I'm looking at it and I'm coming at it from the left side here on the graph, it looks like it's at -2, and we just calculated -2. So I know that I can rewrite that as g of -2. So let's look at the g graph. And g of -2, well, it actually has a value right there. Its value is 0. So I get to use, it's not continuous again. I apologize. I am looking at the wrong thing. Okay. It's not continuous, so I need to pick which side. Our original value was 2, and 2 is to the right. So I'm going to look at it from the right side this time. So I'm going to go the limit as x approaches -2 from the right of g of x. And when I look at that value from the right side, it looks like it's at 0. All right, I'm going to see if I can do good on this last one here. So this should be saying something like f of the limit as x approaches -2 from the left of f of x. All right, so I'm looking at the function from the left side. So f of x at -2 at the left side, oops, sorry. Looks like it's at 3. No, -2 from the left side. I'm doing the right side. So the left side is at -2. So we're going to rewrite this as f of -2. And then if we look at that, we realize that, again, there is a break in the graph at 2. But because I have a value here, I'm above it. So that means I want to look at my limit from the right side this time, because that's where I actually have an existence. So limit as x approaches -2 from the right of f of x. And that value is at 3. Okay. We're going to switch gears up just a little bit. Now we're not working with graphs. We're strictly working with the properties. So this is saying I'm going to take 2 and multiply it by g. So my g value is 6. So I'm going to take 2 times 6, which equals 12. This says I'm going to add the two limits together. So I'd simply add. This is like super easy compared to what we were just doing. This says I'm going to multiply them together. So I'm going to do 9 times 6, which equals 9 times 6. My brain is not working. Did you know you can use Desmos to do this for you? 54. I didn't want to write it down. I was going to write 45. 54. And then F is 9 over 6, which I don't have to reduce in calculus, but I could reduce it to 3/2. And this is, I'm just taking the square root, or F to the 1/2 power. So the square root of 9, which is 3. And that ends today's lesson.